Here we're going to tackle an A-level style question. It normally appears in a Pure Core 1 non-calculator or on a Pure Core 2 calculator paper. The size of the coefficients in the polynomial here would mean that it would probably appear in a Pure Core 2 paper, but we're going to do both examples without a calculator, using synthetic division instead of polynomial division and synthetic substitution rather than traditional substitution. So let's look at the first part of the question, question A. Find the remainder when f of x is divided by x minus 3. So normally we'd use the remainder theorem, and that would tell us that the remainder is given by changing the sign of the number in x minus 3, so changing the minus 3, and substituting it into the function. So normally, traditional method would be done like this. And if it's in a calculator paper, we'd get the result. I'm going to show you the alternative in a moment, but first of all let's multiply this out. So it's 3 cubed is 27 times 3 gives us 81. Take away 7 times 3, so 3 squared is 9 times 7 is 63. Take away 43 times 3, which is 129, and add 15. As you can see, without a calculator this gets rather large, and this is why you'd probably find this question in a Pure Core 2 paper on some examining boards. But nonetheless, we'll work out the solution quickly. 81 take away 63 gives us 18. Take away another 129 gives us minus 111. And adding 15 gives us minus 96. Okay, let's try it using our synthetic substitution method. So I'm going to write down the coefficients of the polynomial. So we've got x cubed coefficient is 3, x squared coefficient is minus 7, the coefficient of x is minus 43, and the units are 15. Remember, this is an alternative to the first method. So if it says use the remainder theorem, we'd use this method up here. If I wanted to be rather quick without a calculator, I'd use this method down here. So again, we change the sign to put a 3 here, and we create this framework for synthetic division. The remainder column is down there. So if there were any missing coefficient, for example, if there's no coefficient of x squared, then we put a 0 as the coefficient. But anyway, let's start by bringing down the first coefficient and then multiplying. 3 times 3 gives us 9. Now we total up this column. Minus 7 plus 9 gives us 2. Again, multiply by the 3 to give us 6. And totaling the column gives us minus 43 plus 6 gives us minus 37. Multiplying by 3, a little bit easier this time, is minus 111. And totaling the final column, 15 take away 111 gives us minus 96 again. And so we get the same answer. The arithmetic is a little bit easier, but like I say, this kind of question with the large coefficients you'd mainly find in a calculator paper. Okay, that's the easy bit. Let's look at the second bit, section B. So for section B it says show that x minus 5 is a factor of x. Now for this, all we do is we do the substitution, we change the sign of minus 5, it becomes 5, and we write down the substitution. But in this case we actually already know, because it's a factor, from the remainder theorem, or more specifically the factor theorem, which says that the remainder is 0 when x minus 5 as a factor, and you put 5 into the function. And all we have to do is make sure we copy the numbers correctly. We nearly made a few mistakes there, and state that it equals 0. And that's enough to show that we understand the theorem, and actually to show that it is there. We don't need to do the calculation in this case, because it simply says show, and we've been told that it's a factor. Now the final stage, and this is normally about 5 marks. So if we look at this, what we want to do is, we want to completely factorize the function. So the first thing we need to do is divide the function by x minus 5. Again, we're going to use synthetic division because it's rather quicker than polynomial division. In part because we don't have to write down as many things. But let's have a look. Let's put the 5 here now, bring the 3 down, multiply again, giving us 15, totaling minus 7 and 15 gives us 8. 5 times 8 gives us 40, minus 43 plus 40 gives us minus 3, 5 times minus 3 gives us minus 15, totaling the final column gives us a remainder of 0. We do not use this method to show that the remainder is 0, because it's a method that the examiners won't be that familiar with. But what it does give us rather quickly is the result of the division. We can read the coefficients here, 3x squared plus 8x minus 3. So factorizing it into a quadratic and the known factor is rather easy. All we need to do now is factorize the quadratic.